Good morning friends, myself Dr. Soumitra Shankar Das. Today I am taking classes for BVOC Department of Home Science, Bisha Agriculture University, and the course Human Nutrition and Dietetics. Today my topic is probability. Okay, so before going to main topics, we have to familiar with some terminologies. Say first of all, experiment. So what is experiment? An experiment is regarded as an act which can be essentially repeated under the same condition. Okay. Next is a random experiment. So what is random experiment? A random experiment is an experiment whose results are determined by a chance factor. That means the result of the random experiment cannot be predicted in advance. Means if we throw a dice, the outcomes are 1, maybe 2, maybe 3, maybe 4, maybe 5, maybe 6. These are the possible outcomes. Okay. So this is called a random experiment. That means if we throw a dice, these are the outcomes. So any one of these outcomes may appear at the upper faces of the die, but we cannot say advance that the outcome 3 will come. So this is called an random experiment. Means the outcome of the random experiment cannot be predicted in advance or determined by a chance factor. Is known as random experiment. Next, trial. If we conduct an experiment by tossing a coin, throw a dice 20 number of times, so this is a random experiment, and each performance 1, 2, 3 up to 20, each performance is known as trial. Next is outcomes. So these are the result of the random experiment. Okay, this is known as the outcome of that particular experiment. These are nothing but these results are nothing but the outcome of that particular experiment. Next is event. Event are certain specified sets of outcome. Okay, that means this is also an outcome for conducting an experiment, throwing a dice. Now see, if we write 1, 3, 5 or 2, 4, 6, these are also event. This is also called compound events, because if we split these two events, we can also write 1, 3, 5, 2, 4, 6. Okay, so this is known as compound event. But these are also event 2, 4, 6, 1, 3, 5. This is known as elementary events, because we cannot further split this event into a simpler events. Is known as complementary events. These are complementary events and these are compound events. Next is mutually exclusive event. Events are said to be mutually exclusive if occurrence of one event precludes the occurrence of other. That means if we toss a coin, either the head or tail will come. The occurrence of head, this precludes the occurrence of tail. Or if we throw a dice, so suppose the outcome 3 is shown in the upper faces of the dice, that means occurrence of these 3 precludes the occurrence of other events. So this is known as mutually exclusive. That means occurrence of an event precludes the occurrence of other one. Is known as mutually exclusive. Next is exhaustive events. Exhaustive events are those, that means total number of all possible outcomes of any random experiment are known as exhaustive events. That means if we throw a dice, this 1, 2, 3, 4, 5, 6 are known as exhaustive events. Next is independent. Independent event are those means occurrence of an event does not influence, occurrence or non-occurrence of any event does not influence by occurrence of or non-occurrence of any other event. I mean to say, if we throw a die first time, may suppose 3 is the outcomes. Second time if we throw a dice, 5 is the outcomes, suppose. So that means 3 in the first process, getting 3 in the first process does not influence getting 5 in the second process. Okay, these are known as independent. That means occurrence or non-occurrence of any event does not influence the occurrence or non-occurrence of other or subsequent events. Okay. Next, we have to define probability. So there are 3 approaches to define the probability. First one is classical approach. This is also called classical, mathematical or priori approach also. What is classical approach? If an experiment is conducted n number of trials, these n are exhaustive, mutually exclusive and equally likely cases, out of which small n are favorable for getting any event, say E. If an experiment is conducted n number of trial, out of which m are favorable for getting any event E, then probability P for happening of E is given by m by n. That means number of the favorable cases divided by total number of the cases. Obviously here n greater than or is equal to m, m greater than or is equal to 0, n greater than 0. So that means whenever m is equal to 0, P of E will be 0. Whenever n is equal to m, P of E will be 1. So that means probability for any event will be lies between 0 to 1. This is known as the classical, mathematical or priori approach. This definition of the probability was given by James Bernoulli. Now see, this is also called a priori approach, since before conducting any experiment we can able to calculate the probability. Suppose if we toss a coin, then probability of getting head is half. Why? Because if we toss a coin, then the total number of the outcome will be 2 and favorable number of cases will be 1 for getting head. Okay. To see, before conducting a coin toss, we can able to calculate the probability for getting head or getting tail. That's why it is also known as priori approaches. Classical, mathematical or priori approaches. This definition has one advantage is that it is very easy to calculate and understand, but some disadvantages is also there. First disadvantages, here some conditions are applied. N is exhaustive, mutually exclusive and equally likely cases. But in most of the practical cases, we cannot find exhaustive or mutually exclusive cases. Suppose if we spray an insecticide on certain insect, either this insect will die or may not die. Obviously these are exhaustive, but these events are not surely equally likely cases. Understood? So this is one of the demerits of this classification. Another demerit is probability of E is equal to m by n. So if n tends to infinity, probability of E tends to 0. Probability of E tends to 0. So see, whenever n getting infinite numbers, probability for any event it reduces to 0. Another disadvantage is if we don't know n, if we don't know total number of events, then we cannot able to find the probability by using this classical approaches. So these are some demerits. Probability of E is equal to m by n. That means in a n number of the trial, if m are favorable for getting any event E, obviously some condition was applied for n, then probability for occurrence any event E is denoted by this. If E is not happen, that means non-happening for any event is known as complementary event, and it is denoted by using this definition. This is the total number of cases and this is favorable number of cases. Now if we discuss about the non-happening for that event is known as complementary event and it is denoted by E complement. So if M is favorable for getting an event E, then non-favorable for getting of event E is nothing but the n minus m, because n is total number of cases. Then non-happening for any event E, probability of non-happening for this event is given by probability of E complement is equal to n minus m by n. Now if we do some mathematics, we can write 1 minus m by n. That means 1 minus probability of E, because probability of E is equal to m by n. Now I can write probability of E plus probability of E complement is 1. The next approaches is relative frequency approach or statistical approach or empirical approach. That is statistical approaches. This is also known as relative frequency approach or statistical approach. Here the definition tells that if an experiment is conducted large number of trial, then the limiting value of the ratio to the total number of event divided by total number of cases or trial are known as probability for that event. That means if total number of event is n and m, total number of trial is n and m are total number of occurrence of that event, then limiting value limit n tends to infinity is given the probability for that event. Probability for that event. This definition gives the validity of the mathematical or priori probability approaches, because see, mathematical and priori probability tells that if a coin is unbiased and we conduct an experiment, then occurrence of probability for getting head is half. It does not mean that if we toss a coin 10 times, then probability of getting head, number of head is 5 or number of tail is 10. But if we conduct experiment in large number of the trials, 1000, 100,000, 20,000 like that, then we can at least get the probability of nearly 0.5 for both occurrence of head or occurrence of tail. So this is known as the statistical or approaches or relative frequency approaches. Clear? This definition is also have some disadvantages. Here, this definition tells that if the trial is large, so whenever trial is large, it is very difficult to maintain or conduct the experiment under homogeneous condition. But here one assumption is applied that the limit should be unique and finite. Okay, this is the statistical approaches. Now we have to discuss about the addition theorem of probability. For any, suppose for any two events A and B, the additional theorem of the probability tells that for any two events A and B, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So this is the addition theorem of the probability. For any two events A and B, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B means occurrence of both the event, either A or B or both, and A intersection B is simultaneous occurrence of both event A and B. And probability A and probability B means probability, you know, probability of A and probability B. Here, if these two events are mutually disjoint, then probability of A intersection B will be 0. So if two events A and B are mutually disjoint, then this theorem is reduces to probability of A plus probability of B. Because for mutually disjoint events, probability of A intersection B will be 0. This is known as additional theorem. Here we have considered only two events. It may be applied 3, 4 up to n events also. Now we have to discuss about the multiplication theorem of the probability. Here this theorem tells that for any two events A and B, probability of A intersection B can be written as probability of A into probability of B for given A, provided that probability of A greater than 0. See, we know that simultaneous occurrence of both the event, probability of A intersection B. Now what is this probability B for given? This is known as conditional probability. This is called conditional probability of B where A has already occurred. Is known as conditional probability of B where A has already occurred is given by probability of A intersection B. From here I can write probability of B for given A is equal to probability of A intersection B by probability of So this is multiplication theorem. Or otherwise, I can also write probability of intersection B is equal to probability of B and probability of A for given B. Condition is probability of B greater than 0. Okay. From here, I can write probability of A for given B is equal to probability of A intersection B by probability of B. So this probability of A for given B is known as conditional probability of A, where B has already occurred. So this is multiplication theorem. See, we also know the independent events. Independent events, the occurrence of an event, occurrence or non-occurrence of an event does not influence by the occurrence or non-occurrence of other subsequent events. If this happens, if A and B are independent, condition is A and B are independent, so for probability of A for given B will be probability of A only. So that means probability for if A and B are independent, in that case as probability of A for given B, I can write probability of A, because occurrence of A does not influence by B or any other subsequent event. So I can write probability of A. So if A and B are independent, I can write from this equation probability of A and probability of B is equal to probability of A intersection B. This is also important. Okay, these are some theorem on probabilities. You see, we are discussing one example here. Problem is, if two dice are thrown, what is the probability that the sum is greater than 8 and B is neither 7 or not 11? Clear? So here two dice are thrown. Okay, if two dice are thrown, suppose S denoted the sum, then we can get what? If S denoted the sum of the result of two dice thrown. So first question is, the sum is greater than 8. The sum is greater than 8. So see, what are the sum we can get for throwing two dice? For greater than 8, it may be 9, maybe 10, maybe 11, maybe 12. If S denoted sum, that means it may be 9 also, S is equal to 10 also, S is equal to 11, and S is equal to 12 also. This is up to maximum. We can get outcomes from a single process is 6. So that means 6 plus 6 will be up to 12, or maybe 6 and 5. These are the sum we can get. That is 9, 10, 11, 12. Now we have to calculate that the probability that the sum is greater than 8. Means we have to calculate the probability of this event. That means probability of S is equal to 9 plus probability of S is equal to 10 plus probability of S is equal to 11, S is equal to 12. Okay. Next, what are the favorable cases for getting S is equal to 9? This may be 4 5 5 4 3 6 6 3. This 4 only. 3 6 6 3. 4 5. This 4 only. Okay. So that means the probability will be for S. Probability of S is equal to 9 is these 4. These 4 are the favorable cases for the getting S, and total number of the total number of cases will be 36. Total number of the cases for throwing 2 dice, this will be 36. Then probability for getting sum of 9 is 4 by 36. That means 1 by 9, or you may keep 4 by 36 also, no problem. Achha. Next is probability of getting S is equal to 10. What are the favorable cases for getting S is equal to 10? This may be 5 5, this may be 5 5, 6 4, or 4 6. That means I can say 3 by 36. 3 by 36. Next is probability of getting S is equal to 11. So what are the favorable cases for that? 5 6 and 6 5. 5 6 and 6 5. That means 2 are favorable for getting S is equal to 11, and total cases is 36. Next, for S is equal to 12, that is 6 and 6 only. That means I can write 1 by 36. Okay. Now if we add all those things, 10 by 36. These are the probability for getting sum greater than 8. This is the result, 10 by 36. Next question was neither 11 and nor B. You can reduce this term also, no problem, or keep as it is. Next problem is neither 7 nor 11. Neither 7 nor 11. That means first you have to calculate for 7 and 11. As we know that total probability or maximum probability is 1. Okay. If we add for S is equal to 7 plus S is equal to 11 and subtract it from 1, then we will get the answer of the second portion. So for S is equal to 7, what are those? 3 4, 4 3, 5 2, 2 5, 6 1, 1 6. So that means favorable cases is 6 by 36 for S is equal to 7, neither 7 nor 11. For 11 it was 2 by 36. So now I can write the answer of the second question there. Required probability for getting neither 7 nor 11 is 1 minus 2 by 36 plus 6 by 36. That means 1 minus 8 by 36. So ultimately I can write 36 minus 8 by 36. That means 7 by 9. This is the answer for getting neither 7 or nor 11. So friend, this is very short about the probability classes. One approaches we have to discuss in next classes. Today we have discussed only the mathematical or priori one and statistical one. Next classes we have to discuss about the